If this gear rotates in this direction, then which direction will this gear rotate? Tell me your answers in the comment section down below and I'll show the answer towards the end of this video. We're going to understand how the differential gear train works as well as where and why we need it. And you can even build your own model to fully see and understand it. You can download my design files for free and have them 3D printed by PCBWay, who have kindly sponsored this video. Links down below for that. A differential gear train looks something like this, and we usually find them located between the back two wheels of a rear-wheel drive car. On a front-wheel drive car, we find it between the front two wheels, and we find one at the front and another at the rear of a four-wheel drive car. However, we're going to stick with a rear-wheel drive car in this video for simplicity. So why do we need it? When a car moves in a straight line, the engine provides power through the drive shaft into the differential, which divides the power between the two rear wheels. This propels the car along, and so the wheels will all rotate at the same time at the same speed. However, when a car turns, the front two wheels change direction, but the rear wheels remain in position. The wheels are now following different length paths. The inner path is shorter than the outer path. So the outer wheels must cover a longer distance in the same amount of time, and that means they need to rotate faster. So the rear wheels need to turn at different speeds. The differential allows the wheels to rotate at different speeds. If this wasn't installed, then both wheels would rotate at the same speed on corners, and this would cause the tires to slip and wear out. The car would become harder to handle, and the forces could even snap the axle. Therefore, we allow the rear wheels to rotate at different speeds to stop that occurring. We can see from this basic model differential that if I hold one of the wheels, the other can still rotate. This is known as an open differential. The problem we face is that if one of the wheels travels over a slippery surface, such as ice, almost all of the engine's power will transfer to the wheel with least resistance, and so the car becomes stuck. To solve that, we use a limited slip differential, and we will see how that works later on in this video. By the way, you can also learn how a car generates electricity in our detailed alternator video. Links down below for that. Let's look at the main parts of a rear differential. First, we find the main housing, which surrounds all the internal components. Somewhere on the casing, there will be a removable plate, allowing access to the internal gears. The casing stops debris from the road damaging the internal gears. It also retains oil within the housing to lubricate the gears and reduce wear. If we remove the housing, we can see the various gears which are attached to the axles. These are supported by a number of bearings to ensure a smooth rotation. The engine will provide power via the input gear, which is known as the drive pinion gear. The pinion gear connects to the ring gear, which is much larger. Notice the gears are spiral cut. They could be straight cut, but a spiral cut increases the contact surface area. In this example, we have 43 ring teeth and 11 pinion teeth, and so the ratio is about 3.9 to 1. A low ratio increases the fuel efficiency, but it decreases acceleration. A high ratio decreases fuel efficiency, but it increases acceleration. So car designers need to take this into consideration. The ring gear is mounted to the differential casing. This then supports two smaller internal gears known as the spider gears. The spider gears are often joined with a small metal shaft. When the ring gear rotates, the spider gears will travel around the same axis. However, the spider gears can rotate on their own axis. We use two spider gears to distribute the forces evenly. The spider gears connect with two other gears known as the side gears. One connects to the left wheel axle, and the other connects to the right wheel axle. The spider gears will allow the axles to rotate at different speeds, while still transferring torque and rotation to the wheels. So let's see how that works. You can also learn how the starter motor and the car battery work in our previous videos. Links down below for that. Let's understand how the open differential works. The engine is providing the power through the pistons moving up and down, which rotates the camshaft. This transfers through the clutch and into the transmission. The power then transfers through the selected gears within the transmission and then out to the drive shaft. The drive shaft transfers this into the differential at the rear of the car. From here, it is distributed out to each of the rear wheels. And by the way, we have covered how the transmission works in great detail previously. Links down below for that. Looking inside the differential, the drive shaft is connected to the pinion gear. This is directly connected to the ring gear. So, the drive shaft rotates the pinion gear, which rotates the ring gear. As the ring gear rotates, the casing must also rotate. And as the spider gears are attached to this, they rotate with the casing. If the car is traveling in a straight line, the force is equal on both rear wheels. So, the spider gears will not spin on their axis as they rotate with the casing. They transfer the torque into the side gears, causing them to rotate, which rotates the axles and tires, propelling the car forwards. The side gears and the spider gears will rotate at the same speed and direction as the ring gear. If the car was lifted up, when we look inside, we can see that all the gears are able to turn on their own axis when needed. If you turned the wheels by hand, you could turn one wheel and the other wouldn't move. You could also turn both wheels together, or you could even turn them in opposite directions. When the car turns right, the left wheel, axle, and side gears must rotate faster, and the right wheel, axle, and side gear must slow down. So while turning, the wheels are both rotating forwards. The left gear is just rotating faster, causing the spider gear to rotate and slow the right gear down. The difference in speed between the side gears is inversely proportional. Let's see what I mean. Going straight, both wheels might rotate at say 300 RPM, but when turning right, the left wheel might rotate at 360 RPM, while the right side wheel rotates at 240 RPM. So while one increases, the other decreases, and the difference is inversely proportional to each other. The best way to understand is to build your own model version so you can see it all in action. I've made this design myself, and you can download my design files for free. Links down below for that. You can just 3D print them, or even easier, just upload the files to PCBWay, who have kindly sponsored this video, and they will 3D print your parts and ship them directly to you. Their website shows a preview of the component, then you just choose the material and submit your order. The component then arrives in the post, and just look at how good this one has came out, especially in comparison to my homemade 3D printed version. I'm really super impressed with this. So we just assemble the components, and then I can play around with the model and see exactly how it works. Nothing beats learning hands-on. So I'll leave a link for you in the video description. Do check them out. They offer everything from 3D printing, CNC, injection molding, and even sheet metal fabrication. Just click the link down below to get started and build yourself a model differential. The problem with open differentials is that they send power to the wheel with less friction, which causes the wheel to slip, and that's not good when the car travels across a surface such as ice. So we need a slightly different design that limits the slip of the wheel with less friction. So we use a limited slip differential. The clutch-based version is probably the most common, so we will learn how this works. With the limited slip differential, we have the same main components: the drive pinion, the ring gear, the casing, the spider gears, the side gears, and the axles. However, we do have some additional parts. Behind each side gear, we find a clutch pack, which consists of multiple layers of two different discs. We have the clutch friction plates and the clutch discs. The clutch friction plates have a special textured surface which increases friction. Part of the disc extends outwards. This will slot into the grooves of the differential case. When the ring gear rotates, it rotates the casing, and so the clutch friction plates will also rotate. The clutch discs are sheets of metal with teeth around the inner edge. These will slot into the splines of the side gears, interlocking the two together. When the side gear rotates, the clutch disc rotates also. However, the clutch friction plates do not interlock with the splines of the side gears, and so they will rotate around it. These two discs are stacked alternatively to form the clutch pack on each side. A spring is then inserted into the middle, which provides a light pushing force, and so the side gears will slightly compress the clutch packs. The friction material of the clutch plates will grip onto the clutch discs. This will temporarily join them together, and so they will rotate together. However, if a certain amount of force or torque is applied to the wheel, then the two discs will break this temporary joint and slip past each other. So, when the car turns, the wheels have to change speed. This will provide enough force to break the temporary joint, and so the side gears can rotate at different speeds, although the main casing will continue to rotate at the same speed. However, when the car travels in a straight line, the friction between the clutch packs temporarily locks the side gears so that they rotate at the same speed. The main casing will rotate with them and provides the pushing force. So, with the limited slip differential, when a car travels across a slippery surface such as ice, the power of the engine is distributed to both wheels, so the car gets some traction and is able to continue forwards. But this isn't possible with an open differential, and so the car will become stuck. Okay, so at the beginning of the video, I asked you if this gear rotates in this direction, then what direction will this gear rotate? And the answer is this. However, we have learned in this video that this is an open differential, and so this gear could also be held in place and all the other gears would still rotate. Did you get that correct? Let me know in the comment section down below. Check out one of these videos to continue learning about automotive engineering. And don't forget to follow us on Facebook, Instagram, LinkedIn, Twitter, TikTok, and theengineeringmindset.com.